So, good afternoon, ladies and gentlemen. My name is Nevena Krasteva. I'm the editor-in-chief of SeeNext, that's a business news agency for Southeast Europe. And I'll have the pleasure of moderating the next panel. So, here with me, I have my guests, my panelists. Krasi Petkova, she's head of ESG at Enery. Then next to her, we have Sergey Petrov, the CEO of Pollenity. Also, we have Martin Banov of the Institute for Soil Research, Soil Science, and we have Professor Zehtindjiev, Pavel Zehtindjiev of the Bulgarian Academy of Science, the Institute of Biodiversity and Ecosystem Research. So, our next panel will focus on an issue that has been very hot ever since the emergence of the first renewable energy projects. And that's the coexistence of renewable energy projects and nature, and which has given rise to lots of heated discussion, like I said, and lots of myths. So with this panel, we'll try to dispel some of these myths, to showcase some positive examples, to see how high-tech and nature and renewable energy projects can go hand in hand, help each other. And we'll also identify some unusual, let's call them partners in crime to renewable energy project developers. So, starting with the lady, with Krasi. Enery, Enery has a very big portfolio of projects. So it employs various technologies, solar, wind, throughout our region, across Southeast Europe. And it's also very, very serious about biodiversity, about conservation and monitoring. So I know that, and many of the people here in our audience know that you've been introducing grazing, sheep grazing at your project. So maybe tell us more about that and other things, other interesting things you're doing.
Thank you, Nevena. Thanks for the question and also for having me in this panel. I think, and I'm glad, biodiversity is now gaining a little bit of power. It's nice to see it next to things like climate change mitigation and adaptation, because it's important for humanity, and it's nice to see that it's gaining traction in events like this. We've had biodiversity as part of our strategy for a while now, but it's good to see it's getting a little bit of a speed. In terms of what we've been doing, you're right, we have some sheep grazing across different power plants. This is actually one of the pilot projects that we started with. We started very small, as probably many other companies. We started with one little project in Czech Republic, where we had a very, very small herd of sheep. We liked the results, and then the next year we implemented some more. Now I think we have about 17 power plants, mainly maintained by the sheep that are grazing around, of course with the help of some mechanical mowing, but that's the way that we want to go, and where possible we would like to have actually sheep grazing our power plants.
Do you have in Bulgaria, sorry to interrupt you, in Bulgaria do you have sheep grazing?
We have sheep grazing in Karajalovo, yes. We are looking to implement them in Zenovo, but haven't yet quite managed yet. The main issue that we have actually is finding shepherds. So let's see how we do. Some of the other
volunteers for shepherds.
Oh, please. Some of the other things that we actually have been working on is, as I said, we started small. We started with things like sheep grazing and planting trees and stuff, but then we moved on to bigger, more ambitious projects like biodiversity monitoring long-term, like introducing habitat features like ponds and forests. So that's something that I'd like to share. As I said, we started a few years ago, I think, with our long-term biodiversity monitoring. We started in Bulgaria with Karajalovo. Maybe my colleagues can share a bit about the results afterwards. But we also then expanded the initiative across other sites. And the learning so far, of course, we've only done it for a few years, so we don't have enough data yet. But so far, what we've learned is solar power plants are not only not harming the environment, but actually they are like a bit of a fresh air, a bit of a safe haven for animals and for different species, different vegetation species, because mainly or very often the surrounding areas are agricultural, so there's not a lot of variety or diversity there. My favorite example by far is from our Sebiș power plant in Romania. We restarted a long-lost biodiversity monitoring campaign when we took over from the previous owner, and what we found in 2022 is that we have a very large orchid population on site, which is something that you cannot see in the area, although it used to be native to the site. It cannot be seen in the surrounding areas because they're mainly agriculture. So this is something that we are trying very hard to preserve. We since then adapted the mowing techniques we're using. We're only doing mowing campaigns in certain times of the year, so we allow the grass to grow a bit higher so that the orchids can survive and they can thrive. But this is an example of how solar power plant has actually been better than the surrounding areas in preserving some of that nature life. And the other example that I would like to share very quickly is we saw, again, from other places, we have natural ponds in some of our sites. We preserve them, but what we are now also doing is we're trying to introduce ponds in Karajalovo in Bulgaria, because we think that this would bring the biodiversity score much higher of the site, and it would help us preserve some of the, or reintroduce some of the habitats that are important for the Natura 2000 area that the site is located in.
Okay, you mentioned orchids, and from orchids, from flowers, it's a very short step to bees. So I know that you're doing lots of things with bees, so maybe just tell us something about it.
I can. So yeah, we like bees, we like honey. We've introduced honey as part of our main ingredient in the Christmas presents that we give to our partners, so maybe some of you guys have received this. But we have many different campaigns. We started with collaborations with local beekeepers. We then introduced bee gardens in our sites, and then hedgerows to increase the clean forage that they have. We don't use any chemicals on our site, so this is good for bees. And then later on, we actually partnered up with Pollenity. We do quite a few things with them. The projects that we started with them grew tentacles, I would say. We really like a campaign that we have with them that we now call Little Bees, where beekeepers in their off-season, this was pioneered by Pollenity, in their off-season go to schools, they tell kids how important bees are for us, they show them a beehive in practice, how it works and what bees do in general. And I think so far it's been a successful campaign and we'll continue it. And the second thing that we started more recently with Pollenity is something that I'm sure Sergey can share more about. It's called EcoPulse, and it's a methodology that we are now implementing in Cenovo, where we are trying to find out what is the diversity around the site through bees.
So, Sergey, to you, tell us more about what Krasi's been telling us, this EcoPulse technology and what it does in practice.
First of all, thank you for inviting us to this panel. I am Sergey from Pollenity, and the mission of our company is to preserve the ecosystems and to help restore biodiversity where it's needed. So we are a pioneering company in that space, as we are trying to do something quite innovative, I would say. We are using the honeybees as sensors of the environment so that solar parks, for example, can have a clear view of what is the state of biodiversity in a clear, in a particular ecosystem, and what could be the contaminants. But first of all, I would like to say why this is actually interesting and innovative methodology. And it's because bees have been particularly good sensors of the environment for millions of years. So if you think about it, you know that bees make honey, and you probably have received some gifts from Enery, which come directly from their beehives. But the other thing that I'm sure you also know about is pollination. So when bees pollinate, they essentially gather the pollen as a source of protein to give to their bees back in the hive, which essentially means that bees quite effectively centralize genetic material from a whole ecosystem into a box, the hive. So what we do with that, we take the pollen. Well, there is a certain methodology. We take samples every week so that we can know that we get pollen from each particular flowering plant in that area. And what we do is basically genetic analysis, DNA analysis to the pollen. So having that, we can give you a very accurate state of the biodiversity to observe native species or to not observe species that are native but should be there, to observe intrusive species that quite literally kill the native species. So when you have that timely and accurate data about the state of the biodiversity, it is up to you to restore it, and it could be quite easy. So you mentioned that you have been doing tree planting. Tree planting by its own, it's a great thing to do, right? But you need to know what exactly type of tree this particular ecosystem needs, and if it's present or if it's not present right now. So we give information about how to accurately react to the changes in the environment in a timely manner so that it could be effective and sustainable. And I'm very happy that Enery adopted this idea, as this has been a dream of mine. I know that bees are good sensors, but up until now, not a lot of companies have been turning to let's analyze biodiversity because it's important. For now, it was just PR. I mean, we buy honey, we sell honey, we create good campaigns, we elevate our PR and brand. But now I'm happy that more and more companies are turning to this because of its actual sustainability outcome. And this is what we do with Enery in Cenovo, and this year we're starting 10 more points, right?
With Enery again, or with other companies?
So in this industry, it's just Enery for now in terms of ecosystem monitoring, but we have customers in other industries as well, like the mining industries and other very intensive industries.
Okay, and apart from clients in the renewable energy sector, how do you help beekeepers themselves? I mean, what the information that you collect, how does that help them?
Oh, that's a great question. Actually, back when ESG was a modern topic, we would tick a lot of boxes in that area, just because beekeepers, well, they don't get the respect that they need. And this is one very simple measure in which you can actually give back to beekeepers, and we all know why they are important to agriculture and to biodiversity, to nature as a whole. So in a way, when you apply this methodology for biomonitoring, what you do is you upskill the beekeepers, you give them more knowledge on how to make a more innovative and high value work, and as a side project, you can also employ them in going to schools and actually explaining all of this to the children, which should be the one generation, the current children are the generation that is responsible for probably saving the planet from what we are doing to it. So again, this is something that we also partner with Enery on. sending beekeepers off-season to visit schools and talk about bees, pollination, renewable energy, and pretty much sustainability.
Okay, one thing I wanted to say but forgot is that today it's the International Biodiversity Day, so it's a nice coincidence and I think a good occasion to really have this focus. So, back now to our discussion. Soils, and a question for Mr. Banov. You know, there's one of the many myths that have been circulating regarding the impact of renewable energy projects is related to their impact on air and on soil. So I know that your institute has been conducting some surveys at large solar project sites, park sites. So could you tell us what are the findings of the survey at Karadzhalovo particularly?
Okay, thank you for the opportunity to be here in this very important meeting. I am from Institute of Soil Science, Agrotechnologies and Plant Protection, which is a national leader in soil investigation in Bulgaria. And first of all, I would like to say that it is well known that the natural resources crisis is characterized by decreasing biodiversity, deteriorating soil fertility due to degradation processes, decreasing water resources, decreasing soil resources, etc. One of the solutions is related to the development of photovoltaic plants. On the other hand, research shows that the construction of photovoltaic plants has an impact on terrestrial ecosystem. To check this information and to determine the impact on photovoltaic power plants on the conditions of soil, in collaboration with Association for Electricity Production, Storage and Training, and together with our colleagues from Bulgarian Academy of Science, a field study of the soil was carried out on the territory of the existing photovoltaic park Karadzhalovo, as Krasi said. So it is in the area of Prvomai municipality. According to this, we took soil samples from the territory of the park in the depth of 0 to 25 or 30 centimeters in a grid, and several samples we took from the neighbor area to compare the characteristics of the soil in the park area and in the neighbor area. The study was carried out in 2 stages. First stage was during September 2022, and the next stage was in May 2023. The location of the samples taken during the second stage coincides with those collected during the field survey in September 2022. All this allows, on the basis of the obtained analytical results, to calculate the influence of the exploitation of the site on the qualities of the soil cover. The collected samples were analyzed for the content of basic nutrients, media reaction, content of organic matter, mechanical composition, and microbiological activities. So, a characterization of the soil differences found on the site and in the surrounding area was prepared. This allowed to compare the condition of the soil cover on the site and soils that are not affected by electricity production. The obtained results indicate the lack of significant impact from electricity production on the state of the soil cover. So this is for the beginning.
Okay, so that's, to put it just in one brief sentence, no impact, no significant impact.
No significant impact.
Okay. Have you conducted other surveys at other sites that lead to some other conclusions or to the same conclusion?
Okay, there is a different conclusion based on our survey. So the most important conclusion from our point of view can be drawn from the conducted researches are the following. As I have already indicated, no significant impact on soil characteristics has been observed from the construction and operating of photovoltaic park. It is necessary to carry out such studies regularly, over a period of several years in order to confirm the results obtained so far. Conditions are created to preserve soils from intensive cultivation for an extended period of time with minimal or no application of pesticides, herbicides and fertilizers and no treatments. This is also related to preserving the health of the soil and restoring its fertility. The need for conducting field studies related to the preparation of annual monitoring reports is demonstrated regarding the short-term, medium-term and long-term impact of the implementation of large-scale systems for the production and storage of electricity from renewable energy sources, on ecosystems and biodiversity, as well as on the quality and sustainability use of soils. The study on the soil in the territories adjacent to the photovoltaic parks provides an opportunity to track the impact that the exploitation of the objects has on the soil cover.
Okay, thank you. It was very factual, very full of details. Just to make sure that I understood right, because it was a bit complicated. So for what period, how long were you monitoring the site at Karađaovo?
We monitoring 2 stages, as I said, during the September 2022 and May 2023. According to our idea, it is normally to prepare such kind of study also after 2 or 3 years. And more important, what I would like to say, that is we have to prepare such kind of investigation before to start construction photovoltaic parks and after during their exploitation. Let's say we have to lead soil investigation before and after to have opportunity to compare the
results, to see what was the situation
yes,
before and
yes.
after the project was implemented. Okay, thank you. From soil to air and birds. So there are lots of very, very interesting things and conclusions that can be drawn from monitoring birds, and I think we really can hear that from Mr. Zehtindjiev. Also, he'll be telling us, I think, about what they've been doing at the Sveti Nikola wind park, but also if we could broaden up the whole topic, and if you could share with us what else is coming up, what are the latest technologies that we have in this area and how they can be applied.
Hello, thank you. Thank you very much. I like these questions. This is my favorite subject. Very often I speak in auditories of scientists or different kind of meetings of colleagues, scientists. And this is my first experience when I speak in a business auditory, which is orientated positively and optimistic about renewable energy. And I don't have to explain all positive effects of this at the beginning. So I hope everybody is convinced in this and I don't have to spend time. So probably the better way is to stand because I have to manage with my presentation. It is a short version. Maybe it makes sense to say in this particular day, today, day of the biodiversity, when we celebrate it, what is the biodiversity? We often say this word and it passes something constant or conservation effort or something that we know exactly. Unfortunately, we like animals, but they don't like us as we like them. So usually, this is a one-way direction off. So they are afraid of people. That's why they feel some impact of our presence in this planet. So biodiversity is a very complex theory. And the most important that we should consider when we speak about monitoring of renewable energy is that this is not a constant. It is not an N given once by God and never change. It is a constant process of creation of biodiversity, which is often skipped by conservation organizations when they think and act in current days, especially about in Bulgaria and renewable energy. The changing environment produces biodiversity. It is also a part of equation. So when we lose biodiversity, and we estimate the reasons for this, it's very important to understand that the main reason for bottleneck in biodiversity now is the global change dynamic of the climate, which provide or push the whole ecosystems to change very fast, faster than the species can adapt to these changes. So our main tool to stop or slow down this process is to slow down the processes that accumulate these gases and activate the warming and dynamic of climate. So every kind of local effect that we estimate in our investigation in respect to planning, construction, exploitation, operation of renewable energy projects, these are local effects. They are important for our social practice, for banking, for economic, but they are not important in respect to global ecology. So what we have in the moment, I will focus on experience. Bulgaria is, in my understanding and in confirmation. Can you start this video or I can start? There is a video in this slide. Can you click on this? Okay. Bulgaria is have a leading experience and accumulated knowledge. Why? Because our government many governments were pushed by NGO sector to act and preserve birds, bats in development process of wind power, especially in the area of Kaliakra. So for this almost 20 years, I'm involved and may say that have overview of and actually history. I know the history of this development of our studies and who did this and the results of this. So what kind of data we have now after these 20 years? The technology of production of wind and photo and energy changed, but also changed all technologies for controlling or monitoring also changed. So now we have and thinking about this, I just have a message. When I was in, let's say, 14 years in the school, we wrote an essay. What will be the world in 2000? It was incredible far day. And believe me, nobody in my class of about 40 people even matched very close to reality, which was in 2000. So the maximum fantasy was that we will fly somewhere, but nobody imagined our communication possibilities. So when we develop our projects now in the moment, we should consider that even grid transmission of electricity will change probably a lot in next 10 years. And the problems that we now discuss probably will be solved by technology. But the big profit of our idea for renewables is changing of people mentality, because we don't need to accumulate something, but it comes every day to us, and we are part of this ecosystem. So what we learned and what data we collected is data how to manage, how to plan, and how to operate these projects. We use many technologies. Radar, this is a very sophisticated radar system. Video cameras with high resolution and software, special software. And we operate this integrated bird protection system for a long time. And the effectiveness of the system is confirmed in different international meetings, also including Berne Convention reports. And the Berne Convention closed the case Kaliakra after many years and considering the results of application of this system. This is about the history, but what we do now, we use, for example, this is already mentioned Super Karađao. It's known in Bulgaria as photovoltaic Super Karađao because it was the biggest photovoltaic park. And thanks to Enery company, and because of this corporate strategy of this company, we started a program of monitoring. So I would like to share this new, I think, a very important innovation. When you use Sentinel, European satellite, which make pictures for controlling of an environment, and we investigated this normalized green index of the vegetation. And vegetation is very important for ecosystem because this is a base for everything. It produces biomass from energy. It is practically a photovoltaic plant, but it makes biomass, which later is transformed in energy. So it's a real photovoltaic park. So we investigated control area and the photovoltaic, and we compared this, and after the results, analysis of the results, we decided to restore some of the habitats, and now the company apply inside a very good management plan of the environment. So another good example is how, for example, you see here the predictions by the model of mortality, expected mortality in collision, and the real collision established after carcass monitoring of 20 years in wind turbines, in 114 turbines. So after over 46,000 individual searches under turbines, it's a unique database, not only in the level of Balkans and Europe, in the whole world, there is very little examples of such rich and long-term database concerning real bird mortality. So this is a big advantage in Bulgaria when we plan these wind plants in the future parks. They can be based not on the predictions, but on the real impact data. So can you start the video? Also during all these start years, we tested many new devices, new technologies, as I said, which can prevent direct mortality. Even it is low enough at the population level, we tested many different systems that can transmit sound, different sound, characters of sound, different type of cameras, infrared cameras, high-resolution cameras. So we now know, based on this experience, please start the video in the upper corner and the next closer. Yes, you see now difference between the radar picture in the left side and the right side, the picture of the thermal camera. The big difference between these two technologies is in the identification of the target. So in the radar you see something that is moving, you never know what species is this, and you need obligatory a field observer that can identify this and give you precise directions what to do with this species. And the second is the camera, which provides much more information in respect to behavior, altitude, kind of movements, so you can estimate the species. Later, please start yes, in the corner down. We use also this GPS technology, which allow you to track precisely movement of single bird. And we install these GPS devices on many, we call them example species. So species that give us, this is a middle-sized raptor species, diurnal raptor, which is most often collision victim in the wind park. So we investigate altitude, behavior, presence during the seasons, and the sample size is quite good to allow us make further analysis in GPS software. So when we do this GPS analysis, we have very precise information about seasonal variation in the altitudes. It is the graphs in the top, and when these species are present in the territory, how they behave during the breeding season, how much is the space they cannot use in the wind farm territory. So what is this displacement effect? Based on all this, we now have a study which is aiming at quantification of the effect, which is missing part in all environmental impact assessments. We stop in the question, did you make cumulative effect calculation? And when we ask how we make this cumulative effect, they say, oh, you should account all kinds of projects, but how you can't account on these projects if you don't know a single effect? So when we have a quantity measurement of this, we can come to quantification of different sizes, even the national scale of effect, and even international and global scale of effect of wind farm. So based on this data, we already know some patterns, how the wind farms, you see, depending on the density of turbines, how they impact the flying birds. So this barrier effect that is very often discussed, and the displacement based on barrier effect, and collision risk are virtually opposite. So they can exist together, but in this case, half of or part of the individuals pass through the wind farm, and another part of the individuals avoid this. So to estimate this behavior, we tested on GPS data of most common white stork migration, and we come to conclusion that the different density of turbines produce different kind of effects, but they can be measured and used, applied in environmental impact assessment. In the current moment, we have these cameras, which are very important for development of current stage wind farms in Bulgaria, because they are economically very, how to say, acceptable. They are serial produced by normal producers, not tailor-made devices, but my team and our study group develop a software, a code that is machine learning system based on pictures taken from the field by this camera in the real wind farms in Bulgaria. So this is a big advantage when you try to educate your software to recognize birds. You don't buy from internet or from a professional, photographs some pictures, because they are very good, but they are not applicable for education of your cameras. So please start, this is the last slide. I will not stretch anymore my talk. There are more, yes, and the down the corner also, okay. So you see here how these cameras work in our practice. They can provide you identification, they upload the information in Excel table, and they can give you signal to stop the production for the time when the bird is endangered in the area close to wind turbines. So here is in contrast the radar, which gives you precise distance, precise information, but unfortunately it does not allow you identification of species, which is crucial, key element in mitigation measures. So this is all. Thank you. I cannot change sorry. The last slide, thank you for your attention. Excuse me if it was too long. As I said, this is my favorite, and I'm very happy.
Thank you so much. It's been really amazing, these insights, the things you're telling us about technology. I never imagined that it had reached so far, employing even machine learning. But one thing that really I think is important is this message that you stressed in the beginning of your presentation. You said that one thing we should do is we should change our mentality when it comes to the renewable energy and its development, to keep pace and to really be adequate in our response. So taking up from there, and because we have to really wrap up this panel, my last question to all the panelists. So despite these positive examples that we've been sharing, that people, some of them are widely known, others not so much, but still there are lots of concerns, fears against renewable energy projects, most of them, some of them intentional, some of them unintentionally fueled. So what do you think, like if we really have to keep it very brief, where should developers of renewable energy projects focus their efforts to really try to convince the public that there's nothing really to fear?
If I may say just a few words, I think also coming off of what Professor Zehtindjiev already said, data is key. If we keep collecting data, smart people will trust us because smart people trust in data. And if we can show with data, not just with feelings, emotions and stuff, with data that our projects are not harming the environment, I think this is the best that we can do. One of the things that we've been trying to do is we openly share what our results are in our sustainability reports. We talk about things in forums like this, but we share with the public, we share with our stakeholders what the results that we get are, because we think this is the only way that we can actually convince people that this is good and this is the way forward. And that's the only thing, I guess, that we can do.
Thank you, Sergey.
Well, thank you. I'd like to build up on that because data is the key to that. As Professor Banov said, we need to establish a baseline. We need to know what is the current state before you build the EV plant, so that you can shut up the people that are trying to, you know, just let's say they attack you for wasting, let's say, arable land. Because when we're using the honeybees as sensors, what we have found out, and this is something that we're working on publicly now, where our food is being produced, there's a lot of pesticides. Where our energy is being produced, there's not pesticides. So just think about that. And I would also like to ask you to become advocates for biodiversity, especially on this day, as biodiversity is for all of us. We are biodiversity, and we desperately rely on its preservation.
Thank you. In addition, what our colleague said, it is very important to start to collect data, to provide data to the community, to be sure that the environmental is not in risk. And what my colleague said, if we have arable lands which are not using during the photovoltaic activities, in the end we can find one arable land which are in very good condition, because it is not used intensively without using pesticides, herbicides, and other activities, agricultural activities. And in our, let's say, data from now, it is good for the soil. But we have to provide another data, another information for the community to be sure that this is true. Thank you.
Thank you.
Oh, thanks. I have actually 2 points. The one is that the current generation is already very difficult to change, so we must work on our children, grandchildren, and probably work for the future, which belongs to the children. But the second, what we can do now is to, when we plan our projects, the best way to make it ecologically sustainable is to think about the species established. So the survey, pre-construction survey, gives you a list of species. When you evaluate these species, try to estimate the ecological time that these species need to adapt to these changes. Ecological time means how fast they breed. They don't have our calendar, they don't know when is Christmas. They measure time, how many times they breed. So depending on how long the species is living, this can be very sensitive, less sensitive, and so on. If we give them chance to adapt ecological time, and the big project is separated in some stages, steps by step, then we provide this ecological time for most of the species. And then they can adapt. Adaptation is a part of life. We cannot stop this, just have to give chance to life to adapt to our presence in the planet. So this is my message.
Okay, thank you. So if I have to wrap it up, it's fight disinformation with facts and data, and also think about the species at the site of your projects and give them time to adapt. Okay, thank you. Thank you to my panelists, and thank you to all.